if you want your students to understand motion, give them the ability to control motion with the new Pasco Smart Cart motor. The Smart Cart motor turns a smart cart into a powered, wirelessly controlled vehicle. It attaches to any Pasco Smart Cart with the 2 included screws and the accessory cable. Just like the Smart Cart, it has a built-in rechargeable battery that can last all day. Of course, it comes with a cable for overnight charging. Its drive wheel works on and off a dynamics track, turning your classroom floor or hallway into a physics lab. The high and low string tie points and the mass tray show it was designed by people who know something about physics instruction. Physics students are told that the force of kinetic friction does not depend on the relative speed between 2 surfaces. The Smart Cart motor is the tool they need to investigate this for themselves. It allows them to drag a friction block at a constant speed while the Smart Cart force sensor measures the force of friction and the Smart Cart position sensor measures the speed. After collecting data for several speeds, the students can create a model of kinetic friction force as a function of speed and decide for themselves if the effect of speed is negligible. Let's see how that might look. So I have a friction block, and I'm going to hook it onto the force sensor. And I have connected the Smart Cart to SparkView software, and then that allows me to display a Smart Cart motor control panel. And we want to set the power to start with. You can set it anywhere from -100 to a +100. Now, because I'm using the force sensor, the motor's in front, so we're kind of going opposite to how you normally would do it. So I'm going to put in a negative value. Let's start with -50 as an example. I've also set up a force and a velocity graph, but not versus time. I set it up versus position because you want to measure friction over the same part of the track every time when you're trying to measure what might be a small effect. So I have everything ready here. The force sensor is zeroed. And if I just hit start, it drags it across the track and stops when I hit stop. The speed pretty constant here, so students could measure the average speed over a certain part here. Force a little bit of variation. Let's select part of that. So what about we select from 0.2 meters to 0.4 to be consistent? You could pick something else if you like. I usually avoid the startup part and then obviously the end where it hit. And if I hit the statistics menu, I get 0.81 newtons for the force of friction. Well, let's see what it's like at a different speed. In the lab activity in the experiment library for this, they would change it by 10 every time. But just to see if there's anything going on, let's bump it to -70. And we hit start. And stop. And let's just see what happened to the force of friction here. And is it going to be the same? Is it different? It is different. It's 0.84. But is that significant? We need to collect more data and do some analysis for ourselves to see if there is some sort of effect. Using Blockly programming in SparkView or Pasco Capstone software, the Smart Cart motor can respond to inputs from any Pasco sensor, including the Smart Cart itself. This creates an endless set of possibilities for using the Smart Cart motor. Many ideas can be found in the activities posted in the Pasco experiment library. These include relative motion, velocity components, programming motion equations, programming the cart to respond to the color of light, and even modeling the motion of earthquake waves. The earth and sky are the limit when your students get their hands and minds on a Pasco Smart Cart motor. Thanks for watching.